All right, welcome back, guys. We're going to continue with skeletal system as far as our material. Let's see where we left off. Okay, we were talking about how the body repairs itself in the midst of a fracture. We were mentioning how your body goes through this hematoma and then eventually forms a splint and then can repair itself. Just remember that even in the act of repairing itself, you can still have scar tissue remaining, and that scar tissue can be something that can be more problematic in the future. Okay, let's talk about the human skeleton. The big thing to understand, if you didn't already know, there are 206 bones in the human body. We need to know that number guaranteed. As an adult, that's typically what we'd expect, even teenage years, right? As an infant, on the other hand, the number of bones that are found are actually substantially more. As an infant, we're going to see somewhere in the ballpark of 300 to 310 bones. And the reason why there's so many more bones as an infant is because the bones have not yet fused together. So there's still this fusing process occurring. So because this fusing process is still going on, there's such a higher number of bones. So as the baby develops, it takes typically 2 years for the bones of the skull to fully develop. As the baby develops, then you're going to get the number of bones substantially lower, closer to 206, as we said. The skeleton is broken up into two major parts. Today's video is going to be mostly about the axial skeleton. What do we find in the axial skeleton? Well, the skull, the vertebral column, and the rib cage. And then there's also the appendicular skeleton, which will be our next video, which is all about the arms and legs, the shoulder, and the pelvis. Okay. This is a great picture, just kind of showing us color coding. In this mint color, that's all the axial skeleton. And then this yellow bone color, that's all the appendicular skeleton. Once again, we'll get into the axial skeleton. It's 3 parts: the skull, vertebral column, and rib cage. I actually really do like this diagram a lot, just because it shows every single bone that we'll need to know for this unit. It may look a little overwhelming now, but don't worry, we'll get there. Okay, let's start off with the skull. So the skull is going to be made up of 2 sets of bones: the cranium, which is basically everything eyebrows and up, and then the facial bones, which are the bones that make up your face. The skull bones are joined together by these joints called sutures. We're going to talk about that in the coming slide. And then the only bone relating to the whole skull that is going to be freely movable is the jaw, the mandible. The mandible is able to move very freely, obviously, because when we talk, your jaw moves up and down, right? Not to mention the mandible also moves when we're eating. But every other bone of the face or the skull does not move. It is locked in place. Okay, what is the purpose of the cranium? Simply put, protect the brain. The brain is very sensitive, so you got to make sure you protect it. That's why you have this helmet type structure. The bones are attached together, like we mentioned, by these sutures. I would just make sure that we know that term, so we're comfortable with the word suture. Now, we'll learn more about joints in a future video, but joints typically help to provide movement and mobility. What makes sutures so unique is that they do the exact opposite. They're still a type of joint, but they are immovable. They're like a glue. The bones of the cranium are made up of flat bones. I would make sure we know that. As far as our classifications of bone that we talked about previously, they are all flat bones. Remember long bones, short bones, irregular bones, flat bones. The bones that we have the frontal, parietal, occipital, and temporal. We got a slide coming up on the next slide that's going to show this a little bit better. And then finally, the foramen magnum. The foramen magnum is going to be the opening of the occipital bone. It's basically a big hole. Foramen, it means hole. Magnum means big. So what do we have in that area? The spinal cord. It's where the spinal cord connects directly into the brain. We'll talk more about that in nervous system when we reach that unit. Okay, this is one of the best diagrams that you're going to see regarding the skeletal system and regarding the skull. So we really need to know a couple of these. So I'm going to circle them one by one. We've got the occipital bone here. The occipital bone is referencing the back of the skull. Why do we call that the occipital bone? Because if you've taken a little bit of other courses, the back of the brain, that's known as the occipital lobe. So they're the same name. And the occipital lobe is all about vision. Then we have the temporal bone. The temporal bone is going to be this orange colored region, and it's all about your temples. I always think of Professor X when he's like using telekinetic or psychic abilities, right, in X-Men. But it's that orange region, which is going to be where the ears are. The temporal lobe in the brain, it's all about hearing. Then we have parietal bone. The parietal bone is going to be this massive green region. The parietal bone is going to be more responsible for sensitivity, or the parietal lobe, sorry, is going to be more responsible for senses and how your body responds to those senses. The sutures, we don't need to worry about that. So don't even worry about the sutures. That's stuff that's a little beyond where we're at. Frontal bone in this gold yellow color, that's going to be literally the front, right? As far as the frontal bone is concerned, it goes from like your eyebrow region a little lower all the way up to above your hairline. Now, the face bones, there are a couple face bones that you can see. However, the only ones that I need us to understand are going to be right here, maxilla and mandible. Maxilla is the upper jaw, whereas mandible is the lower jaw. That's all, right? In general, that's 6 bones of the skull. Not bad. We can live with that pretty easily, right? Okay, so let me go ahead and erase this. Okay, moving on. This is just another viewpoint. This is as if you were holding the skull in your hand and you were looking straight into it. The only thing that we can see here that we haven't already seen in the last picture is the Foramen Magnum. Once again, that is this big hole right here. And what's going to be found in there? The spinal cord. All right. Another view. This is an inferior view. This is as if you were holding the skull and you had it above you and you were looking into it. Again, don't matter too much about that. We're going to kind of just skip through this pretty quickly. I don't expect you to have to know too much about this for testing purposes. But the fetal skull, or even just the skull of a newborn baby, is rather different compared to an adult, right? Obviously, size is a big part of it. What we observe, though, is we have these gaps that are found in the skull, these gap regions that we see here and here and here. Now, why do these gaps exist? They're called fontanelles. The purpose of them is they act like a fibrous membrane that connects the bones together, but it allows for the brain to grow and, in turn, the skull to grow. Like I mentioned earlier in this video, it takes up to 24 months, 2 years for the skull to fully form. So quite some time. Okay, rolling on. Regarding the facial bones, the 2 big ones that I need us to know, like I showed you guys before, is the maxilla and the mandible. So make sure you know those 2. The maxilla is going to be the 2 bones that form the upper jaw. Mandible is going to be the bones that form the lower jaw. Remember, it is the only movable bone. Now, the maxilla and the mandible have teeth sockets for teeth. There are 32 teeth because there's 16 on the top, 16 on the bottom, 16 on the top. Teeth are very similar to bone. They're often confused, but they're not the same. They're their own type of tissue. Nasal bone. I don't talk about the nasal bone too much. Most of the nose, when you look at a skeleton, and you'll see it on the next slide, in fact, is gone. That's stuff that will decompose within months of dying. But the bridge is a bone. In an action movie, when you see somebody get punched and you hear that cracking sound, that's the nasal bone, the actual bridge getting damaged. What I always find interesting in a lot of action movies is like anytime that somebody gets punched like with a hook, and a hook is like when you're carrying force in one direction. So like let's say a right hook is carrying force towards the left. Well, that can cause the nose to twist towards that angle. And if you don't get it healed, if you don't get it fixed back, if you don't get it repaired or snapped back into position, it can heal angled. And for some people, that happens to them where they never treated the nose when it should have. And when it heals up, it's literally in an awkward angle, and that can cause breathing problems. Then finally, the zygomatic bones, they form your cheeks, right? We talk more about that in muscular system because of the muscles that form the zygomaticus, stuff that we're going to learn down the line. Okay, here we go. Again, I know it's a little blurry, this picture, so don't worry too much about it. But once again, you can see how the nose is gone because it's just cartilage. Once again, we're going to see this picture here. Make sure that you're comfortable with the 6 that I circled earlier in this video. Okay, vertebral column. Let's talk about that. The vertebral column is made up of these individual vertebrae. The vertebrae are separated by these discs. You've probably heard of a herniated disc before. It's when the disc starts to slip. That can be very painful and can be a pretty tedious procedure to fix it. The spine has normal curvatures. So here's what we observe. The spine, even though we're bipedal and we stand straight up, right? The spine is not just perfectly vertical. It does have these natural curves that are expected. So the curves is going to be something along the lines of this. That's expected to be in our spine. Each vertebrae is given a name according to its location, and we've seen those names back in Intro to Anatomy, those videos that I recorded much earlier. So, for instance, the cervical region is going to be your neck region. Thoracic is going to be your chest. Lumbar is going to be lower back. You may have heard of chairs that have great lumbar support. That means they're really good for your lower back. Sacrum is going to be this strange, to me, honestly, when you look at the sacrum, and you can look this up online if you'd like, it reminds me of like the face huggers from Alien or Aliens, the Ridley Scott movie, how they just kind of jump at you. It looks very similar. It's strange. And then at the very bottom, we have the tailbone known as the coccyx, right? I primarily focus on these three guys right here, cervical through lumbar. Now, the function of the vertebral column, most important function is to protect the spinal cord. The spinal cord is a very sensitive nerve. You got to make sure that it's protected. It supports the rib cage. Every single rib comes from the spine. So it supports the rib cage, and the sacrum and even the coccyx are directly connected, more so than the sacrum, are directly connected to the pelvis or the hip. So it does help to support the hip. Now, remember how I was mentioning we need to know cervical through thoracic a little bit more in detail? That is true. So I have a mnemonic that can help us out because the thing that I need us to know is going to be relating to how many vertebrae are found in each region between cervical, thoracic, and move that out of the way, cervical, thoracic, and lumbar. So here's my mnemonic. To remember how many vertebrae are in each region, I think of the three most important meals of the day. So let's start with breakfast. What time is breakfast? 7 o'clock. Why 7? Because there are 7 vertebrae in the cervical region. What's the next meal of the day? Lunch. What time is lunch? Noon, 12 p.m. Why 12? Because there are 12 vertebrae in the thoracic region. Finally, what time is dinner? Granted, this is mostly like an early bird dinner because growing up in a Hispanic household, we wouldn't have dinner till like 8 o'clock, 8:30, 9 o'clock sometimes in extreme cases. But in this circumstance, with our mnemonic device, dinner is going to be at 5 p.m., early bird dinner. And why 5 p.m.? There are 5 vertebrae in the lumbar region. We need to know this. This is 100% something that you're going to get asked about again, especially when we do nervous system, because the nerves are very similar to the amount of vertebrae that we have. So we're going to learn about this more down the line. But if you can learn it now, you're in a good place. All right, so let's continue moving down in just a second. Okay, finally, we're almost done. Got the rib cage as far as for this video. Regarding the rib cage or the bony thorax, I never really call it the bony thorax. Rib cage is perfectly fine. It literally forms a cage to protect the major organs, such as the heart and lungs. It is made up of 3 parts. First off, there are 24 total ribs, 12 on each side, right? The parts of the ribs that we need to know, we have 3 distinct categories: true, false, and floating. True ribs are the ones closer to your pectoral muscles. They're closer towards the top parts of your body, so they're going to be the ones that are directly connected to the sternum. Those are ones that are typically tougher to break. False ribs, they do connect from your backside, right? But they kind of stop near your obliques. Now, because they stop near your obliques, they do connect to the sternum, but they utilize more cartilage. So it's not as sturdy as we'd expect it to be. But when you breathe in, and your lungs expand, that's what's opening up. Your rib cage opens up to allow the lungs to expand even further, and it's the false ribs that are mostly doing the heavy lifting here. And then finally, the floating ribs. These are ribs that are found in the lower back region. They are only found in the back. They do not even extend to your sides. They're very, very tiny, and they do not attach to the sternum, obviously. And we'll see what they look like in just a second. Okay. Here, honestly, the big thing that I need you to know is that the sternum is considered to be a flat bone as far as the classification is concerned. In future units and future courses, you may learn more about the manubrium and the xiphoid process. The xiphoid process is pretty interesting because it's connected to the diaphragm. That's a tissue that we're going to learn in respiratory system. It allows you to breathe. But we don't need to worry too much about this stuff, so we're actually going to move on pretty quick. Okay. And finally, to finish this off for today, here's the rib cage. again, I think the sternum, to me, it kind of reminds me of like the tie. Let me circle that. It kind of reminds me of the tie of the body. Right? A little necktie. It does its job, right? The heart is not perfectly behind it because the heart actually sits at a tilt to your left. So the heart would actually be closer to here. But it does protect a good chunk of the heart, no doubt. Here we can see how the first couple ribs, the first 7 ribs to be exact, are considered true ribs. Those are the ones that are directly connected to the sternum. These are more sturdy. Then we see the false ribs. The false ribs, it depends, right? Sometimes it's up to 8 through 10. Sometimes it's all the way to 12. It just depends on the person. These are the ones that can make it to the side of the body and then connect all the way to the sternum via cartilage. And then finally, the remaining ribs that don't even make it to your sides are going to be the floating ribs. These are the ones that are mostly vestigial. The reason why we have them in the first place is because we had an ancestor, as far as our species are concerned, that had a larger chest. So that ancestor likely had those ribs go all the way around it in order to protect the body better. But our bodies are much smaller than our ancestors, so we don't need it anymore. It's a vestigial, right? It's something as a remnant. All right. So other than that, guys, I think that's a great place for us to stop for this video. We'll continue moving forward. We're making good progress at this section. I know it's a bit of a longer one, so thanks for tuning in. Thanks for keeping up with me. But yeah, other than that, we're all set. I hope you guys have a great one. Enjoy the rest of your day.